Okay, so for the first exercise, I will start from a new drawing, a fresh drawing from the mechanical millimeter template. And before I get started, I want to make sure that, again, I download the folder of this exercise, because we will be inserting a block from this folder later into our in this exercise into our drawing. So I'll just go to the BricsCAD Mechanical Training V21, exercise 9, sheet metal from scratch. And actually, I will just download this entire folder. Takes a while. Well, anyway, meanwhile, I'll just get started. Okay, right here. So download this entire folder. Okay, I'll get started by just first of all drawing a rectangle. So using the rectangle or polyline tool, and I'll just start off here in the origin and create a rectangle of 100 millimeters wide and 255 millimeters long. And I'll turn this rectangle into a sheet metal feature or a sheet metal entity, namely a flange. So I'm going to create a base flange. If I hover over the polyline, if I'm using the mechanical workspace in the quad, I should be able to see a new tab here called sheet metal. We'll be using this tab a lot here for these following exercises. Otherwise, it's also possible to go to the sheet metal tab in the ribbon here, and you will find similar options. So I will highlight this polyline and click Create Base Flange. I will just accept the default settings and press Enter. And now I will see that this object is actually a base flange for sheet metal. So it's actually a solid which has some extra functionalities. For example, it allows me to easily create new flanges based on this flange here. For instance, I can create a flange here based on this edge. So I need to make sure for this exercise that I have my prioritization of edge selection enabled, as well as faces. We'll be needing both of these options. I'll start off by highlighting this bottom edge here. And under sheet metal, I see I have a couple of options. I can create things like this teardrop hem, an open hem, and so on. And I'll start off with this flange edge here. So I'll just, based on this edge, create a new flange. And see, it gives me the option to change the length and the angle. For this, I'm going to be using the tab key to switch between the two different fields. So this is also something we'll be doing a lot in these exercises, so make sure to get familiar with this tab key. I will start off by creating a length of 13 millimeters, and hitting tab, I will give it an angle of 90 degrees from my base flange. I can hit tab again to change this value if I want, or I can just press enter to create my flange. I'll do the same on the other side here, on this back side. So again, create flange edge. But now, instead of using the entire width of this edge, I am going to choose a sub-option of this command. I'm going to change the width. And it allows me to change or to give it an offset from both sides. So one side at a time. I'll start off with an offset of 32 millimeters here and press enter. And then it will ask me for the offset on the other side, where I will also use 32 millimeters. And now I get the same option as before, so I can change the length and the angle. So I'll choose a length of 62 millimeters and an angle of 90 degrees. And there it is. And I'll just create a new flange here again, length of 13 and an angle of 90. I'm just following the instructions from the handouts, so all the dimensions of this object can be found in the handouts as well. Now, this is now one solid with these sheet metal features in here. If I open my mechanical browser, I will see this extra tab here called sheet metal, and it has some properties, like for example, the overall thickness of my sheet metal object, things like the bend radii, and so on. Now, this is all part of this is all governed by these global values here. So this means if I change my thickness to, let's say, 5 millimeters, the entire object's thickness will change to 5 millimeters. Or if I change my bend radius, currently it's defined as a ratio of my thickness, so it's 1 times the thickness of my object, which is 2 millimeters. I can change this ratio to 3, for instance, to have larger bend radii. For now, I'll just keep the default values. By the way, so all of these flanges and bends are using these global values. It's also possible to individually change them. If I select, let's say, this bend here, I can change its type to, let's say, a thickness ratio and make this one individually a bit bigger. So it's possible to use global values or to use custom values or custom situations for specific locations. All right. Now, because this is a sheet metal entity, my thickness will always remain the same no matter what I do. So, for instance, if I push-pull this face here, you will see that actually also the backside of this flange moves with it, and the bends as well. So everything remains connected. Everything remains as it's supposed to be because it's smart enough to know that it's a sheet metal feature. However, if I would dissolve this, so there's this dissolve option, I can choose to dissolve this face, and you see it turns into a different color. That's also something, by the way. So there's this option called color features. And basically what it means that a certain feature for sheet metal will be painted in a certain color. For example, bends are yellow, flanges are blue, junctions are orange, I think. You can also change the settings, of course. But you can see here that now this flange here, or this face, is no longer blue, it's gray. That's because it is no longer a sheet metal flange. It's actually just a solid face. If I would now push-pull it, I can see that this is not how it's supposed to be. This is no longer sheet metal, of course. So I'll just Control Z, undo, until before I dissolve it, so I still have my full sheet metal entity. And I'll just continue creating some more flanges. In this case, I will create 2 flanges symmetrically. So I will take these 2 bottom edges at the same time and create 2 flanges with a length of 66 millimeters and an angle of 90 degrees. I'm going to do the same for this edge here. So it's actually fairly intuitive to create these kinds of flanges. 25 and 90. And finally, these small flanges here. All right. Good. I'm going to insert some slots into this this object here. For this, I will be using the library panel. I'm going to use some standard parts, some standard holes. So in the holes folder here, I should be able to find a slot. Now, before inserting it, I will change its parameters, change diameter to 5 millimeters and the length to 40 millimeters. And I want to place it vertically here in this face. Currently it's being placed horizontally, so I will have to, oh, sorry, I accidentally pressed enter. Five millimeters, 40 millimeters. And I will choose rotate component, or just enter R in the command line, 90 degrees. And I will place it here with a certain distance from the top edge, so that's a distance of 30 millimeters from the top edge. Again, using the tab key to switch between different fields, and 12 millimeters from the side edge. Now, as you can see, I see this entire red solid. That's because it's the subtract layer is still enabled. I can turn it off to not see this anymore, but still have my hole in here. Actually, before I do that, I'm going to mirror this hole. So I'll select it. Again, there's multiple ways of mirroring. The way I like to do it is by using a manipulator. So I'm going to move the manipulator to basically my mirroring plane, holding down the control key and choosing mirror, and then choosing a distance of 0 millimeters. And it's mirrored like this. All right, finally, we're going to add some chamfers in the model. So I can do this individually. For instance, I can take this edge here and choose a chamfer. But actually, I'm going to apply the same chamfer geometry, or the same chamfer, to multiple locations. So I'm going to select multiple locations at once. So you could select them like this individually by just picking them. Or you can use the selection box like this, for instance, hitting the control key twice, changing to edge selection mode. So depends on what you prefer, of course. So I have my 6 edges selected. I can also check it in the quad here. 6 solid edges. I will chamfer them all over the same distance. I will choose 5 millimeters. And I will do the same for these 2 bottom edges here, but I will use a larger distance for the chamfering. I want to have a chamfer of 50 millimeters. Like this. And now I'm going to create some more holes, some more slots in this object here. For that, I will use a prepared or pre-made DWG. That's the one I mentioned before in the 24/7 panel. So I will call the insert tool. Browse to the correct location. So in the folder, sheet metal from scratch, holes 2D. I will choose to explode it. I can also do it later. I can uncheck this and explode it manually later. But in this case, I will choose to explode it upon insertion. And using dynamic UCS, make sure it snaps to this top face here, and just snap to this corner. And because I exploded them, they should be all separate lines and circles and polylines, which is good. I'll just select all of them at once, and using the extrude command, so under the model tab here, just extrude them downwards, so you can see if I go upwards, they actually create new solids. If I go down, it will extrude or subtract, sorry, from my existing solid. And I'll just left click to accept it. And now finally, I want to turn this into, or I want to unfold this so it's readable by a machine, by a cutting machine. To do that, I will just simply highlight one of the faces of this object, and under sheet metal, go to unfold body. I'll just place it somewhere in my drawing and press enter. And just like this, it automatically unfolds everything for me and shows me what the bend radii are for all the different bends, shows me where to cut, and so on. So that's one way of creating sheet metal. It's starting from a flange and just building it up from there, adding new flanges and creating holes, things like that. Another option is to create first a solid, shell it into a hollow model, and turn it into sheet metal. And that's what the second exercise is about. So I will, for the second exercise, again, create a new drawing from the mechanical template, mechanical millimeter template. And I will start off with just a simple box. With a length of 200, width of 100, and a height of 100. I will chamfer this edge here. So under model chamfer, and choose a distance.